Welcome, everyone. We're very excited to have Hank, the lead consultant architect with David Kent Consulting, join us this afternoon. And he's going to visit with us about Oracle Cloud Infrastructure. And with further ado, Hank, it's all yours.
Well, thank you. Thank you so much. I'd like to begin by saying that just as a personal note, with COVID and all the crap that's going on, it's so hard to stay optimistic and positive. I am optimistic and I am positive about what's happening in our industry with cloud. It does excite me. And I hope that at the end of this session that you will have some of that excitement, that you'll share in that excitement and the possibilities that can come into play with cloud. I'm going to go ahead and share out my screen. And Dave, if you could confirm, if you could confirm that you can see my display.
I can see it, Hank.
Okay, wonderful. Thank you. So today's session is regarding an introduction to Oracle Cloud Infrastructure. We're going to demystify the Oracle Cloud for you today. But before I begin, I would like Dave to introduce David Kent David Kent Consulting. So go ahead, Dave. Thank you.
All right. Thank you very much, Hank. I'm David Kent, and I'm president of David Kent Consulting. We're a group of experienced Banner, Oracle, and cloud professionals who provide functional and technical services to our clients in higher education. As always, our goal is to help you get the highest possible return on your investment in Banner. Our focus for Cohesion Summit 2020, however, is helping you to bring a higher level of manageability to your infrastructure. Hank, take it away.
Thank you. I appreciate it. Oh, brother, so I got to work with you now. That's how my first day in the cloud business was. It was very, very foreign to me and very difficult. But it's like eating an elephant, a little bite at a time. And the more of the cloud elephant that you eat, the better you get at it. So it's a mountain, but you climb it a step at a time. So what are we going to learn today? We're going to learn about the Oracle Cloud Infrastructure. And at a high level, Oracle Cloud is a combination of compute, storage, networking, and application platforms that will support both legacy and native cloud applications. And when I talk about application platforms, I'm talking about things like database as a service, containerization as a service, MySQL as a service, Tomcat as a service, functions that actually run in the cloud. There's a lot more that's going on in cloud than just doing something like a lift and shift of Banner to the cloud. However, we are focusing this presentation on specifically of the parts of cloud that make sense to look at for doing the lift and shift of Banner to the cloud. The main components that we concern ourselves with when it comes to a lift and shift of Banner to the cloud is infrastructure as a service for those parts of the Banner system that cannot go into a database appliance or into a Kubernetes service. We are, of course, very concerned with the database as a service because the database can run on a traditional VM, but the smart way to run it is as a cloud appliance in the Oracle Cloud. It is comparable to AWS's remote database services. Not shown here on the slide, but of course we're concerned as well with the Kubernetes service that runs in the Oracle Cloud when we talk about containerizing your Banner application when you lift and shift to the cloud so that you have an entrance and operations and maintenance, and if necessary, an exit strategy to and from the Oracle Cloud. The cloud should be considered to be elastic and dynamic, whereby it can scale out and scale up based on your workload requirements, and then it scales back down and back inward for when the workload demand is not there. We call that horizontal and vertical scaling. We want the cloud to be elastic because we want to squeeze as much value as we can when we move Banner to the cloud. It also offers us things like real push button disaster recovery. We can do things like drive the infrastructure as program code so that we can have a more manageable platform and do more with the same number of people that we have. And the Oracle Cloud in general is very high performance, and it gives you the equivalent performance of the AWS Nitro machine without the Nitro price. A typical Oracle enterprise cloud architecture looks something like what you're looking at here. I've heard it said many times, what was old is once again new. And so what I think that can be said in another way in the cloud space is all the disciplines that we've learned to practice over the years should not be thrown out the window. We need to continue to practice good design and architecture whenever we deploy to a new platform. So from an IT management and leadership and from a technical perspective, just view the cloud as another platform that you are designing for. You want to have a rock solid design and strategy before you move to the cloud so that costs don't get out of control, so that manageability doesn't get out of control. We have a term in the industry called cloud fatigue, and what cloud fatigue is defined as is a partial or complete reverse migration from the cloud back to on-prem. A rock solid design and strategy that is aligned with the mission and the strategy of the institution is the way to go. In this diagram, you see that we've got a gray bar that separates two regions. We've got US Ashburn, which is in Virginia, as the primary region, and we have US Phoenix as the secondary region. This could certainly be inversed, and there are more regions that are online now across the United States and Canada and Europe and elsewhere than when I had done this drawing a few months ago. And that's going to continue to be the case where there'll be more and more locations where there will be data centers, that's what a region is, in the Oracle Cloud to give it closer physical proximity to where you and your customers are. And in this scenario, we have container compartments, and the compartments are basically a logical container that holds cloud resources. And in each container, we have VLANs, subnets, database appliances. We get an RMAN appliance. We've got traditional VMs, and we've got, as you can see, a Kubernetes cluster for managing the front end or the web tier for the ERP system. In addition to that, we have a compartment for managing the cloud itself, which includes cloud automation in the form of code that runs as runbooks. We've got a scheduler service, which is either, as an example, that could be Ansible CLI, for example, called from a cron job. It could be Ansible Tower, Ansible AWX. We've got object storage that's holding all of that information. Then we desktop services, and we also have web application firewall, and a VPN connection to the on-prem network. I see I have a question. No, okay. And then you see in the lower quadrant of the screen, the disaster recovery region. And you'll note that we've got file storage running there. We've got a database server there, but everything else is grayed out and is a representation of what the disaster recovery environment could look like. And when it comes time to do a disaster, or if we have to declare, then we play runbooks, which again is infrastructure as code, and the entire infrastructure is brought to life in the disaster recovery region. We practice and we drill that every few months. We get very good at it so that if a disaster really happens, then we can quickly recover. The compartment hierarchy is different from other cloud providers. First of all, compartments span regions. That is actually, from my perspective, very innovative, given how you can write code and how it can make you more efficient to write the code to manage the infrastructure. And you can see in this scenario, we divide up. We have 3 compartments. We've got a compartment for admin computing. We've got a compartment for academic computing and one for student computing. And then underneath the admin compartment, we've got a hierarchy of compartments for various functions that will run this particular Banner tenancy. A network looks pretty much like a topology for an on-prem network. Now, there are arguments for and against segmentation in the cloud. There are arguments to be flatter in the cloud. There are arguments to have a hierarchy of networks and heightened security in the cloud. My professional recommendation is to favor a high degree of segmentation and a high degree of security to protect against the multitude and the plethora of threats that are affecting higher education. Every week when I pick up the journal or I go online and I catch up on what's happening with security, I'm reading about another higher education system or an institution either in the United States or elsewhere that has been compromised by ransomware thieves who are hacking in, threatening to destroy data, and they walk away with a big paycheck and you walk away with a big budget deficit. So I can't stress the need for the security enough. And that's why I favor a higher degree of segmentation. You can see in this scenario in DR, we're flat, but DR is not running all the time. And the only thing that's running in DR typically is a database machine. Everything else is you fire it up when you need it, you pay for it when you need it, and when you shut it off, you're not paying for it anymore. Remember, cloud is elastic, and that's part of the cloud elasticity that I was talking about earlier. Okay, so virtual machines in the cloud look just like virtual machines in VMware. It's a different GUI interface, or it can be driven from code. But I do advise you that as you think about cloud, to not treat the cloud like a VMware box. Doing so will unnecessarily increase your costs, perhaps so much that your cloud costs may be higher versus remaining on-prem. However, if you plan it out right, you have the right architecture, the right strategy, then virtual machines are powered on and powered off based upon need, and your cloud costs will be equivalent or somewhat less than your on-prem costs. The database tier looks pretty much like what you would have on-prem, but the significant difference that we advocate for, which certainly doesn't have to happen, you can run your admin pages. You can run SSB on virtual machines, but we don't advocate for that. And the reason why we don't advocate for that is because you can't scale up quickly if you need to for increased demand. Number two, you're doing more work to standardize across multiple VMs versus building out one container and then replicating that container every time you need another instance running to support more workload. And remember, you need an entrance strategy and you need an exit strategy. And it's very good to have that bargaining chip where say you go into the Oracle cloud, your contract is now resetting 5 years later, and Oracle wants to jack up your contract price by 25%. Well, sure, that's fine, Larry Ellison. I'll just go down the street to AWS where they're coming in with a bargain that I can't say no to. That'll usually get a sales rep to go to his or her manager and seek an approval for a deviation from that 25% uptick in the contract price. And you can see in this scenario, we've got the database servers on the left. In the center, we've got a VM where we create that Docker containers. That's a Tomcat machine, and admin and self-service instances that are created and then are containerized, thrown into a container registry, and then those get fired up with infrastructure as code into the container store. You can see on the far right, we've got our web application firewall appliances that are providing the level of security that we need to keep out signature attacks as well. We've got to properly protect this stuff from the hackers. And the containerization service, you can see a little more detail here. And here you can see in the lower right an example of running at night. So it's nighttime, our utilization is low. So with code, we shut down 2 of the Kubernetes node pools. Node pools are what give us the compute that we need to support the front end. So what we typically do when we do a build is at night, we shut down the capacity we don't need. We still are resilient within the data center region by spreading that workload across 3 data centers within the region. But when people come in the morning, we have another bit of infrastructure code that fires off and it starts up, say, a second node pool, and now we have doubled our workload capacity. And then if we're in a peak business cycle, like a peak finance cycle or a peak registration cycle, then we fire up a 3rd node pool, and then 24/7 during registration, we're running with 3 node pools, and we have no complaints about performance. Conversely, we can, before a peak business cycle, if we know when they are, and it's not difficult to predict these things, we can scale up a Banner database, an ODS database, a DegreeWorks database with more processors and handle the increased database workload so that the database and the web tier come up to the workload requirements concurrently, and then they come down concurrently so that we're only paying for the capacity that we're using. Now, Oracle has a technology called out-of-box networking. And well, as I say in the slide, well, why do I care about out-of-box networking? The physical adapters in Oracle Cloud, they are physical adapters in the machine frame that get bound directly to a para-virtualized kernel that is running the machine instance. This is regardless as to whether it's a virtual machine database, a Kubernetes cluster, or an infrastructure as a service virtual machine. And those dedicated interfaces are not shared by other virtual machine resources. The physical resources then therefore do not suffer from what we call noisy neighbor syndrome. And what noisy neighbor syndrome is if your tenancy is running on the same frame that that other tenancies are running on that have nothing to do with your organization, and you've got a noisy neighbor in another tenant, and that can slow you down. That can happen in Azure and AWS. In Oracle, it is highly unlikely that that will happen because the kernel has been tweaked by Oracle. It is truly para-virtualized, similar to legacy HP and IBM RISC-based technology, where it's a hardwire connection that's made from the computer's bus to that adapter and to the processor and memory. What does this mean? It means you get near equivalent performance of what you would get with physical infrastructure. And in many cases, the VMs for an equivalent type of processor in the Oracle Cloud will outperform VMware infrastructure that is on physically on the campus. Greater than 90% of CPU time is available to the kernel and the user applications. Your storage IO, you can pump 296 megabytes per second, that's megabytes per second, per virtual machine database instance with a 0 to 2 on IO wait time, almost no latency between 0 and 1, which is equivalent to some pretty expensive storage if you were to build that on-prem. Network switches are non-blocking and are not over-provisioned. And what we end up with is what queuing dynamic researchers call a steady state machine. One of my pastimes is to read queuing dynamics and to play with queuing dynamics math. And it is the irregularities in a computer's queue that creates the greatest havoc. That's where you've got these scheduling algorithms, this caching that's going on. SGA is a good example, but you've got disk caching, et cetera, and so forth. And all of this caching is to account for a non-steady state that can occur within a computing machine. Oracle's infrastructure, cloud infrastructure, is as close as I have seen to the steady state machine in the cloud. I think the only other cloud vendor out there that comes close is IBM's SoftLayer as far as a steady state machine in the cloud. And again, I've mentioned that you're getting the Nitro performance at a fraction of the AWS Nitro cost. Are there any questions? Okay. So the database as a service, what is it? Well, when we take all the marketing away, it's an Oracle Linux Enterprise virtual machine that has already been pre-configured that launches when you create the virtual machine database. And it is bound to a database container. It's actually kind of cool in that the database container is decoupled from the virtual machine, or what's called the service node. And when the service node launches, once it's been configured, then the Oracle software that's running in the cloud will pull off the shelf a database container image, and it will build it on top of either logical virtual, on top of LVM file systems, or preferably on top of ASM with grid control. So the grid control and all the software that's behind it, all the hardware, the Linux operating system, and the Oracle Home, and a basic instance of Oracle database are within 30 minutes to an hour and a half. They're built once you actually launch this virtual machine. And it takes a lot of the effort to build an Oracle database from scratch. It eliminates a lot of that headache. Not all of it, but a good deal of it. Additionally, you could do Oracle RAC in the Oracle Cloud, either in bare metal or in virtual database. And with virtual database, you're constrained to up to 2 nodes. However, that's still a lot of capability because you can throw a lot of procs at it and you can throw a lot of IO at it. And when you talk about 296 megabytes per second times 2 sustained throughput with near zero latency, that's a lot of power. And most institutions will never require that kind of IO. You can see in this scenario, we've got OEM running in the cloud, and we've got an RMAN appliance, and we've got some file storage running there. And then of course, we've got our cloud network that connects to the campus network. Excuse me. So you can run rack in the cloud for true database tier resiliency. That does come at a cost because then you've got to pay for the feature set called extreme performance to get that, either with bringing your own proc licenses into the cloud or by paying for the Oracle licenses in the cloud. Rack supports, again, up to 2 nodes. That is a typo. That's supposed to be 296, not 396 megabytes sustained throughput per node. You have full data guard. Edwin, if you could make a note that I need to fix that typo and push a new slide up. You've got both standard and active data guard available. Of course, that's in your Oracle license set. And generally speaking, for bare metal, meaning do you go bare metal in the cloud or you comes cost effective when you're running 12 or more containerized Oracle database containers concurrently in the cloud at a time. And there's variance with there, so don't think that 12 is the magic number. It really depends on your situation and your workload requirements and how you're licensing Oracle in the cloud. Furthermore, when you're doing bare metal, in order for it to be truly effective with rack, you would have to be redundant with that bare metal. And the smallest bare metal frame that's available in Oracle Cloud starts at about $250,000 a year. So I would think twice, more than twice, before selecting bare metal for moving Banner into the cloud. So the licensing, you've got 2 models: bring your own license or pay for the Oracle licensing in the cloud. Your mileage will vary greatly based upon how you're licensed for Oracle Cloud now. In most cases, if you're on a campus agreement, you cannot bring those licenses with you into any cloud provider, whether that be Oracle, AWS, Google, Azure, or somebody else. You got to read the fine print. I know of 2 institutions, one in Texas and one in another state, that actually negotiated a contract reset to allow them to bring their campus agreements into the Oracle Cloud. So check your agreement. The probability is if you're on a campus agreement, you can't bring those licenses with you into the cloud. However, if you decide to move to the Oracle Cloud and lose your Oracle campus agreement after the migration, Oracle will give you 50 cents on the dollar as a credit against your campus agreement for every dollar of cloud spend you have while that migration is taking place. You just want to time it so that your campus agreement doesn't reset while you're in the middle of a migration. Okay, so savings can be substantial for losing the campus agreement when you go into the cloud. Savings can also be substantial, and we've had a couple of use case studies where it might be cheaper to lose your processor-based licensing when you go into the Oracle Cloud because there is a maintenance cost that's associated with that processor licensing. The real determining factor is if you're extreme performance, for example, and you're not restricted use through Ellucian, meaning you've bought those licenses directly from Oracle, the maintenance cost on that is really high. And so in those cases, it's probably cheaper to get the licensing in the Oracle Cloud instead of bringing your Oracle processor licenses with you. And remember, you've got to pay attention to that campus agreement if that's what you're running on for licensing, and when that resets versus when you actually complete your migration. When you know the date, then using the words of Covey, begin with the end game in mind. And the end game is we have to have everything done before that campus agreement resets. And we have to give Oracle the contractual notice to not renew, whether it's 60, 30, 90 days. I've seen some variance in contracts with that. So you got to look at all the I's, dot all the I's, cross all the T's, and then get everything lined up so that you get your migration done on time. You do not want to be late and pay for the campus agreement another year than is necessary. For disaster recovery, your best approach is to use DataGuard to replicate to a standby database in another region. With DataGuard enabled, you can expect to have an recovery point and a recovery time objective at 0/6, meaning near zero data loss, and 6 hours recovery time, operating at disaster recovery tier 5. If you do a Google search on the 7 levels of disaster recovery, there's a nice Wincyclopedia document that covers the background on that. If you are really tight on cash and DataGuard is not in the budget, then you should expect an RPO of 24 hours/24 hours, operating at disaster recovery tier 4. In either case, your disaster recovery should be performed as infrastructure as code, so that if you need it, you run a playbook and you're up and running. Technical disaster recovery plans should be developed, but they should be driven by functional and business requirements. Therefore, ideally, you have a business continuity plan, which is your policy that is aligned with organizational mission and strategy and objectives and is funded, and then develop the disaster recovery plan. Running infrastructure as code, you have many choices. The 2 predominant choices are Ansible and Terraform. We recommend either Ansible or Terraform as your tool to deploy the cloud infrastructure. The other automation platforms, being Chef and Puppet, that are primarily out there, are less supported. The development communities are a lot smaller, which means you have to do a lot more people work to get the same amount of output. By running infrastructure as code, you move towards a DevOps model. You have a high degree of consistency, and you treat your cloud infrastructure as version builds, and you promote the code just like you would in a Banner ERP environment. I have a question.
Yes, an anonymous attendee asks, do we need application continuity JDBC drivers on Tomcat if we use Active Data Guard as our DR solution?
I don't know the answer to that. If you could write that down, and if the anonymous attendee would let us know what their email address is, then we will check with a subject matter expert who knows that. I don't know the answer to that. All of the tools can handle both orchestration and configuration management, with the exception of Terraform. Terraform just does orchestration. If you want to learn more about Terraform, I'm doing a 1-day workshop tomorrow. Ansible and Terraform are well supported by Oracle, and GitHub is an integral part of these products as far as a software repository is concerned. Knowledge of Python is highly recommended. If you already know another language, then picking up Python is not difficult. But if you're new to programming, as was talked about during the Birds of the Feather this morning of DBA Technical, you should probably learn another language like Java or PowerShell before stepping into Python. You can build hybrid wrappers where PowerShell wraps Python, that wraps Ansible. There's just a lot you could do with code. I would recommend that Ansible is the ideal choice for small to mid-sized institutions where the knowledge level of the staff with Python is low, where the controls are perhaps not as strong as they should be. On the other hand, if the knowledge level of the staff is very high, and if the controls for maintaining integrity of operations and maintenance in IT are very high, then Terraform is a good choice. Well, that's all I have on that slide. Here's an example of, we've done a number of cloud-ready assessments. It's a service you could talk to Tom and Dave about if you're interested in. And so here's one scenario that we ran the numbers on. And you can see that compared to a small institution, and the comparator on this, I think was, I don't see it, I think this was Azure. There's a 22% savings of running in the Oracle Cloud versus the other cloud provider. And that's with a bring your own license scenario with an RPO RTO of 24/24. Here we have a medium size, and mind you, that number there is a 5-year number. That's 5 years. Here we have a 5-year number for a mid-sized institution with an FTE of 10,000, Banner, ODS, DegreeWorks, DataGuard, with disaster recovery operating at tier 6 for an RPO RTO of 0/6. The total 5-year cost for Oracle Cloud in this case is $948,000, and for AWS $1.2 million, which represents a 30% savings of going in Oracle Cloud versus AWS. Again, these are real numbers, real cloud assessments that we have done. And then a large institution with over 10,000 for an FTE, we looked at the OPEX for Oracle Cloud over 5 years was 1.247 million or 248 million versus Azure, where it was 1.57 million, which was a 17% savings. Now that's interesting because if we go to the previous slide, we see that our spend does not increase that much when we go from 10,000 to over 10,000. That's where you're getting a lot of economy of scale. And this is true in about any industry that you operate in. So in summarization, Oracle Cloud is a high-performance public cloud with out-of-box networking. And it delivers a very high performance at a much lower cost than AWS and Azure. Of course, we know that Oracle leadership, including Larry Ellison, are behind in the game, and they are playing catch up. And you can benefit by locking in a 5-year contract with a cost that is significantly less than other cloud providers. Pricing models are bring your own license or buy in the cloud. And usually it is better to bring your own licenses into the cloud, but that's not always the case. It depends again on how you're licensed with those processor licenses, how many of them you have, and what do you need for workload and features when you get into the cloud. The key to going to the cloud, and this is regardless as to whether you use us, somebody else, or do it on your own, is to get the architecture and the design right. Don't do this without a roadmap, without a design, and without a strategy to execute. The cloud is elastic. It can scale horizontally, and horizontally we're talking the mid-tier, and vertically, which is the database tier. based upon what your requirements are. To make effective use of the elasticity and the scalability of the Oracle Cloud or any cloud provider in that case, you should be implementing infrastructure as code in a DevOps model. We have a question?
Yes. Mike S. Has the following question. Is there a direct connect option to connect Oracle Cloud to our on-prem? Is latency an issue if only using VPN?
That's a great question. The answer is yes, you can peer directly from your network to the Oracle Cloud, just like you can do so with AWS and Azure. The cost can be very substantial because you have to pay for the LEC or the CLEC to provide the internet service. That'd be like Verizon, AT&T, et cetera, and so forth. Cogent is another example. So you'd have to pay for that service to get to Oracle. And you have to pay for the peering connection. And ideally, your connection, you've got two connections that are running. You're keeping your VPN nailed up as your redundant connection, and your primary connection is the nailed up peered connection. In most cases, but not all cases, this is not something you need for running an ERP system in any cloud provider. There are exceptions, and those exceptions are typically schools that are in rural areas that have spotty internet service. I think that that will change over time when we talk about technologies like Musk's StarNet, which is a satellite constellation at low orbit, which is going to be very high bandwidth. The Air Force is testing it right now, and they're getting in excess of 700 megabits per second on a jet flying in the sky with Starlink. So you can imagine how it will be with a ground station. So they're not advertising it with commercial capabilities, but I think that's coming. So for the rural schools, there might be a future where you won't need to have a direct connection to an internet provider. Or say a direct connection to a cloud provider, but through connection peering. For most institutions, like there's an institution that we provide managed services for in the Virgin Islands. And their distance, in this case, they're doing it with Azure, but the physics are the same regardless of the cloud provider. So they're going to Virginia from the US Virgin Islands, which is a distance of 1,800 miles. And so the latency on that is not significant, and the users have not noticed a significant difference. We see a mathematical difference, but from a functional perspective, there's no prem versus in cloud.
There was a pause.
Okay. But it is important, and I say again, it is important that any adjacent integrated systems and any mid-tier applications be moved to the cloud with the Banner database. And specifically, I'm talking about applications that are sending many packets that are chatty from what they're running on to a Banner, to the Banner database or to an ODS database. And there's something called long fat network. If you query long fat network, there's a Wincyclopedia document, and you can actually see the calculus in there. And there's a good description in plain English that explains what that is and why latency becomes a problem if you don't move your integrated apps and your entire web tier with the ERP system in one swoop.
We have another question.
Yes, sir.
An anonymous attendee has the following question. Do you know any information about making use of Fast Connect if the school is an Internet 2 consortium member? Is the performance stable using Fast Connect with Internet 2?
I do not have direct experience with that, but I do have experience with Internet 2. And Internet 2 is simply a separate network, transport network for data for higher education and research. Therefore, in my professional opinion, you have a less congested network that will probably perform better versus the common internet for transport on a directly peered connection to any cloud provider, Oracle Cloud included. Does that address your question? Okay, thank you. Finally, we recommend that you have the cloud expertise before you pull the trigger and move to any Oracle cloud, any cloud provider, whether that be Oracle or anyone else. And that expertise certainly could be built up in-house. We can certainly help you with that, as I think we have demonstrated through our multiple sessions and tomorrow's workshop. But there are other choices out there, and choice is good because choice gives you the opportunity for us and other vendors to compete for the value of your business. Are there any remaining questions that I could address today? I wish we could actually talk and see each other, but the webinar is what we have today.
Okay, another anonymous attendee has a question.
Yes.
I talked to OCI sales representatives. The cost of Fast Connect will be very reasonable if the school is already an Internet 2 consortium member.
This is true. The reason why the cost would be reasonable is because you are benefiting from the buying power of that internet connection over Internet 2 from your institution to the cloud provider. And again, this is regardless of who the cloud provider is. I'm sorry?
3 minutes.
Okay. But look at the numbers and compare them to the relative cheapness of an IPsec tunnel, of a VPN tunnel. You may not need to pay for this. The Oracle rep may be presenting it to you as a possible option, but it is rare that we see bandwidth requirements for that. Now, on the other hand, if you're going to be building cloud native applications, and if you're going to be doing research on your campus, and you're going to use Oracle Cloud for running some of the compute and storage for that research application, now I'm starting to see justification for that kind of cost. For an ERP system in the cloud, it's my opinion that the numbers just don't work. I really don't care what anyone says. The VPN is so much cheaper versus direct peering. That's my professional opinion. Are there more questions? We're almost out of time. Then I thank you very much, and I turn it over to the chair.
Thank you so very much for attending this session. Great session, Hank. Thank you, David King Consulting. I hope all of you join us for our closing session that begins at 3 p.m. and have a wonderful afternoon and enjoy the workshop tomorrow as well. Thank you.
Thank you. Goodbye.
Bye.
Thanks, Shannon. Have a great day.
Thank you.